notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos so far. Section 1, number theory and computation. All 33 of those videos have been published on YouTube in their entirety. Section 2, consumer arithmetic. All 12 of those videos have been published on YouTube in their entirety. And section 3, sets. All 6 of these videos have been published on YouTube in their entirety. So that's a total of 51 videos from sections 1, 2, and 3, all published on YouTube in their entirety. Please make good use of them. Section 4, measurement. This is the 6th of 16 videos, and I'm somewhat behind schedule. By January 2025, hopefully. Statistics, section 5. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, hopefully, vectors and matrices. Please note this disclaimer. The schedule is just a projection which may or may not be fulfilled. Reminder again that section 1 I have subdivided into 33 videos. All of these are available in their entirety on YouTube. All of these that you see here on the left. They form the foundation of the rest of the syllabus. Please make sure you look at them and know them very well. Another reminder that you need to know the times tables from 2 to 12. If you don't know it, you would have to learn it. And you need to do that because calculators are not allowed in paper 1. Section 2, all of these 12 videos, as I said, have been published in their entirety on YouTube. Section 3, all of these 6 videos have been published in their entirety on YouTube. We are at section 4. This one and this one have been published on YouTube in their entirety. This second video here, third and fifth, are only partially published on YouTube. So we are now here, objective 4 in section 4, length of arc of a circle, and this is actually video 6 in this section. This will only be partially published on YouTube. So this is a print screen of the syllabus. We are here just so you could keep track of where we are. Calculate the length of an arc of a circle. Once we finish with this objective 4, we have 5 more objectives on this page here. Take us to objective 9, plus 6 more, which should give a total of 15 objectives in this section. So as I said, we are here. Calculate the length of an arc of a circle. And this here is given as explanatory notes. Actually, it's not so much explaining, it's an addition to what is here. And that is perimeter of sector of a circle. So these are the 2 things we are going to do. We will find the length of an arc of a circle, and once we find that, we will then find the perimeter of a sector of a circle. Of course, there are certain terms that we need to clarify. So consider the disk shown here. This disk, The red line around it is called the circumference. Now, if we take the correct size protractor and place it at the right position on this disc, you will notice several things. So that is the protractor. By now, you should know that this instrument is called a protractor. Notice it starts here from 0 and goes all the way around like that to the right to 180, or if you begin on the right at 0 here, you come all the way around like that to 180 here on the protractor, not on the disc. So the protractor goes from 0 to 180 in either direction. This is the center of the circle, and we have placed the protractor such that this point here falls exactly at the center of the circle. If you draw a line from one side of the circumference through the center to the other side of the circumference, that line is called the diameter. It's actually two radii opposite each other. And this here, this protractor here, covers half of a circle, which is 180 degrees. Keep that in mind. Half of a circle is 180 degrees. Now, if we draw two radii, which is plural of radius, some other features will appear. So if we draw a radius here, a radius is a straight line from the center of a circle to the circumference. We draw one like that, and another one like this, somewhat apart. So you have two radii. From that point where that radius touches the circumference to this point where this other radius touches the circumference, that part of the circumference is called an arc, A-R-C. Now the area formed by those two radii and the arc is called a sector. If you join any 2 points on the circumference, in this case we are joining this point here and that point there, we get what is called a chord. Now remember, the sector is everything in here, everything in here. Just to be clear, sometimes learners may find it difficult to differentiate between sector and segment, between sector and segment. So let's clear that up. So this is our circle or disc. We have the circumference at the edge here. The center is, of course, in the center here. If you draw two radius from the center to the circumference, we have an arc formed at this part of the circumference is called an arc. The area here between the two radii and the arc is called a sector. That's a sector. Now, if we draw a line from this side to that side here of the circumference, that line is called a chord. This part of the circumference here is called an arc. It's another arc. Now, the space here between that arc and this chord is called a segment. So please don't get mixed up or confused with those two. In geometry, a sector is the area of a circle between two radii and an arc. That's here. This is the sector. Two radii and an arc. While a segment is the area of a circle between a chord and an arc. Between a chord and an arc. There is a special case where if you draw the two radii opposite each other, then, like we have here with this red line, that now forms a diameter. It is also a chord, because a chord is a line that joins 2 points on a circumference. So this is an exception. In this case, a sector is now the same as a segment. But that's an exception. So we said if half of a circle is 180 degrees, then the whole circle will be 360 degrees. Now, if we know the angle that the arc subtends at the center, we can express that as a fraction of 360 degrees, which is the same fraction of the circumference. Remember, we want to calculate the length of the arc of a circle. If we could find the whole circumference, and we know the angle at this point here, then we can easily express that as a fraction of the whole circle. So let us say this angle here is 60 degrees. Then this arc here is 60 over 360 of the circumference. 60 over 360. Remember, 360 is the whole circle all the way around, of whatever the circumference is. So this arc here, from here to there, is 60 over 360 of the circumference. If the angle there were 72 degrees, then it would be 72 over 360 of the circumference. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. So everything you see on the slide here, we just did. But please note that this is from your syllabus, where it says arc length, and the symbol for arc length is an uppercase S, is equal to the angle over 360 multiplied by 2 pi r, and they tell you what that angle is. Theta is the angle subtended by the arc, measured in degrees. So you don't have to memorize this formula. It will be given to you in the exam for CSEC on the formula sheet. As a matter of fact, this print screen here is from the formula sheet.